Hey guys, welcome to Code Templar. This is lecture 4 of FAANG Series. So we'll be solving one interesting problem, count servers that communicate. This is Leetcode 1267. Okay, so let's get straight to the question, what it is being asked. So you will be given a matrix m cross n where 1 means that there is some server, okay, and 0 means that there is no server at that particular index basically, okay, at that particular ith jth index, okay. Now you have to return the number of servers that communicate with one another. And how the communication is going to happen? Two servers can only be communicate if they are on the same row or on the same column, okay. So let's check example 1. In example 1, as you can see that at 0th 0, 0 index we have one server, but at 0, 1 we don't have any server, and similarly 1, 0 we don't have any server, but at 1, 1 we are having a server. So the communication possible? No. For the first server, which is at 0, 0 index, there is no server along the same row, neither along the same column. So first server won't be able to communicate. And same goes to the server which is at index 1, 1. Okay. So here none of the server will be able to communicate with each other. Let's get to example 2. In the example 3, as you can see, we have a server at index 0, 0, 1, 0 and 1, 1. So let's check for 0, 0 index. It won't be able to communicate any server along the row, but it will be able to communicate along the column. Okay, so there are two servers for this. As of now, we saw that two servers can communicate. Now let's go at index 1, 0. Obviously, it can communicate along the row and along the column as well. Okay, so for this, it can communicate with server at index 0, 0, and it can communicate with the server which is at index 1, 1. So the total number of server basically which can communicate with at least one server is 3 over here. Okay. Now let's get to example 3. You will see in row 1 there are two servers which can communicate with each other. In row 2, row 3, row 4, row wise communication is not possible. But let's check the column wise. For column 1, communication is not possible. For column 2, communication is not possible. But for column 3, communication is possible. We have two servers in the same column. Okay. So these two servers can communicate. For row last row, there is only one server. So they can't it can't communicate with any other server. So in the complete, we saw that there are four servers which can communicate with each other. Okay, so this is the problem statement. Let's jump to the approach. Let's take one more example. Okay, and this is one of the corner case where most of them thinks that the output of this will be 0. Okay, but it's not like that. The output of this will be 3. And how it comes? In the first, second, third example, we saw that the servers were connected with each other. I mean, like if this is the server, the next server was placed at this particular index. Okay, and we thought that two server needs to be placed adjacent of each other, whether in the row or in the column, but it's not like that. Okay, if it is placed anywhere in the row, okay, then this will be able to communicate. Okay, if it is placed anywhere in the column along the same column, then this will be able to communicate. So the output in this case will be 3, not 0. Okay, now let's jump to the solution. Okay, So let me take an example which we are going to solve. Okay, so basically if you'll see other videos, they have solved, they have what they have, I mean there are many approaches to solve this problem basically. Okay, you will see everywhere this approach, that we will make a row array and we'll make a column array. Okay, and we will basically be storing the we'll be basically storing the number of server along each row. Okay, so let's, how many rows are there? There are only two rows. Okay, 0th row and one row. Similarly, there are two columns, 0th column and one column. So let's say we will traverse. At row 0 we have server. Okay, so we will update the count. Initially 0 will be there and we'll update the count. Similarly, it's row, it's column 0, we'll update the count. Now we'll check at this index, there is no server, we don't need to update each other. Now at row 1, okay, row 1 basically we'll update the count. This is column 1. Okay, so we'll update count over here. Okay, and when we'll go to this element, row 2 will be updated, I mean this row will be updated, so we'll update its count, and column will be updated to 1. Okay, and again we'll be traversing this array once again, and what will be our condition? Basically at each index we'll see if this grid, basically sorry, if the grid, I mean if in this matrix this is 1, I mean that particular index is having 1, means their server is present, and the row element at that particular index is greater than 2. Okay, or the column element basically at that index is greater than 2, then we are going to update the server. So the condition is like this: grid I of j equals to 1, and row basically I is greater than equals to 2, or column j greater than equals to 2, then we are updating the total plus plus. This is basically this will be the output actually. Okay, so let's go at this index. At 0th 0th, the column value is greater than 2, as you can see, but this is not greater than 2, but this is our condition, and the this condition satisfies. So initially our total value will be 0, it will be updated to 1. When I'm at this index, the row is greater than 1, is basically 1. Okay, I mean this condition does not satisfy, so we are not going to handle this, we are not going to basically handle this. Okay, at this index basically the row value is greater than 2, also the column value is greater than 2, so I'm going to update its value. Okay, at this we satisfy this condition, and row of I, basically row of I, what is the I value here is 1, and the column value here is 1 basically, 1, but since row of I is greater than 2, then I'm going to update its value by 3. So the answer here will be 3. Okay, so basically what I am going to do is I am going to count the number of server in each row, and I'll make a row array and will be updating in that row. Okay, at that index basically. Similarly for column, for each column I'll be having the total number of server, and I'll be updating into the column array. And this is the condition if I'll be traversing this matrix and I'll be checking if I comma j, basically index, the server is there, basically the value is 1, and row of that index, ith index, is greater than 2. I mean, in that row there are 2 elements, or in that particular column the number of servers more than 2, equal or more than 2, it means that server will be able to communicate either via row or either column. Okay, and hence we will add that count into this total count, which is basically the output. Okay, so this is my Leetcode solution. Okay, and you can see that grid matrix is being given as an input, and with that I extracted the value of m, which is the number of rows, and n is basically number of columns. And I have initialized two more arrays, rows and columns, with m and n. And what I'm doing, I am traversing the grid array basically, and if I'm checking if the value is 1, then I'm updating the rows array rows array, and similarly the columns array at that particular index I and j respectively. Okay, and basically the rows will be storing the number of server which is placed along that row, and similarly the columns array will be storing at any particular index. Basically, let's say take it 2, means at column 2 how many servers are there, it will be storing that value at its index. Okay, and now once again I am traversing the grid array, and I'm checking if the grid value is 1 at that particular index, and if row basically is greater than 1, I mean at that index the number stored at row array is greater than 1, or either in columns array, it means that there are more than there are more than one server along that row or along that column. So what I'm going to do is, means if there are more than there are more than one server along that column or either row, then that server will be able to communicate. So I will update the count in this answer integer, and I'll return the answer. Okay, and so this is the simplest solution. What's the time complexity of this approach? So if you'll see, we are traversing the array. So m comma m into n basically is the time complexity, and space complexity, since it is in the order of n. Basically we are having two array, um, m and n, whose size is basically m and n. So the space complexity is the order of n, and time complexity is basically the order of m comma m into n basically. Okay, so this is the solution.